Hey everyone, and welcome to day 2 of LeetCode. Today we're going to continue with arrays and hashing and do two sum. This is a problem that I've had no problem solving in ON squared time, but have had a problem solving in ON. And honestly, I feel like to solve this, you just kind of have to know the solution and understand it, and from there on, use what you've learned to apply to other problems um, in the future. So if you don't get it, I'm in the same boat. And if you do get it, congrats, you are talented. Anyway, so the whole premise of the problem is given an array of integers nums and an integer target, return the indices I and j such that nums at I plus nums at j equals target, and I does not equal j. You may assume that every input has exactly one pair of indices I and j that satisfy the condition. Return the answer with the smaller index first. So, um, here we have the nums equals 3, 4, 5, 6, and target equals 7. And output would be 0 and 1 because 3 and 4 equals 7. 3 plus 4 equals 7. So at index 0 and index 1 would give us the answer to the target. So the solution for an ON squared would look like this. If we were to draw an array, let's just say we're drawing the one where we wanted to get to 7, where target equals 7, okay? And this can just be any number. Let's just say x, y, z, and let's just say that these are integers. And we'll put d. I don't know, that doesn't really follow the whole. I just thought of d. Anyway, let's say we wanted to find what two indices would get to target. The way we would usually do this in a brute force algorithm would be through a double for loop. So we would start with I equals 0, and we would start with j equal to 1, and we would iterate one after the other to the indices to find what target equals to 7. Now this is easy since I equal to 0 and j equals to 1 already equals the target. So nums at I plus nums at j already equal target. And that's just the brute force algorithm. You start with one index, and you go through the rest of the array and find which one equals to the target. If not, we move I up, and then we check the rest of the indices from I onwards to see if it equals target. Now, let's try to do the more optimized way. To do that, we can first create a hash map. So we need to store what values we have already seen. And to do that, we have to put it in and populate it in the hash map. So for example, to do so, we can create a for loop that goes across all the indices of the nums array. So for I in range len nums. Okay, and here we want to populate something into the array. But first we need to check a condition. We need to see whether the difference of the specific current index in the array, minus the target within the hash map. So we can name this difference, and we can say nums target minus nums at I. So we need to do, now we can do if diff in hash map, then we return hash map at I and I. Else we need to actually populate the hash map. To populate the hash map, we need to populate the exact value of this current array and the index. So we can say hashmap at nums at I equals I. And we need to return something, so we can just return empty array, but we are always guaranteed a solution, so this should always work. So here, what's happening is that we're going through each index of the array, and we're checking whether or not the difference of the target and this current index value was already seen. If not, we would just populate the current index value in hopes that this may be a possible solution for a future result, right? And as a result, we can run this, we can see that it's accepted, and then we can submit. And we messed up one place. Let's see where we did that. Default dict int for I in range len nums def equals target minus nums at I. If diff in hashmap return oh, it's not hashmap at I, it's hashmap at diff. Run, submit. Right? Because we want to return whatever the index at diff was at. So, yeah, I hope that made a little sense. I know I'm not there yet in terms of explaining, but I hope it made a little bit of sense on how we achieved this solution. If there's any way I can improve, let me know. I'm sort of learning to explain my solutions a bit better because I know that's something I struggle with. I hope you enjoyed this video, and catch you next time for the third problem. Thanks.